We have been receiving numerous requests from teams for help with programming, especially with help making turns. In this video, we are going to show you how to write a program in MyBlocks for making precise turns using the Yaw Angle or Gyro sensor for the Spike Prime. The following instructions will work in either Spike App 3 or the Spike Legacy app. The first thing you want to do is open the Spike app and select your Spike platform. Create a new project and select MyBlocks as your programming language, or open an existing project written in MyBlocks. If your hub is not connected to the computer yet, you will see a yellow connect circle in the top left corner of your programming canvas. A connected hub will show a blue circle and the status of any connected motors or sensors next to it. Clicking on a connected hub icon will open the hub dashboard. On the hub dashboard, you will see the name of the hub that is currently connected to the app, the hub OS installed, and the battery charge level. Furthermore, you will see a description of your hub and which ports have motors and sensors connected with their respective status. Above the hub picture, you should see a line that shows the current reading for the yaw, pitch, and roll sensors, with the most important being yaw. This will be a good place to check the actual reading of the yaw angle sensor when you stop a program after a turn to see which angle the robot is actually pointing to. To go back to the programming canvas, click on the X in the top right corner of the window. A very common misconception is made when using what we call the move steering block. Putting a value into the oval steering value field does not turn the robot to that many degrees. When you click into the variable field, you will see a depiction of a steering wheel that will show you how severe your turn will be and in which direction. Here we are showing 5 examples for going straight and right turns with explanations of what these blocks will make the robot do. Please pause if you want to read them. Keep in mind that any positive number between 0 and 100 will turn the robot to the right, and changing the variable to negative numbers will change what the motors do to the opposite and will make the robot turn to the left. The example blocks on the top of the screen will make your robot turn forever, so you will have to specify before what speed and how much you want your robot to turn. At the bottom, we are showing another version of the move steering block, in which you can define the number of wheel rotations in the same block. Instead of rotations, you could also choose centimeters, inches, motor rotation degrees, or seconds. Please note that time-based driving might have different results based on the battery level. In order to turn to a certain angle, the yaw angle sensor has to be reset. You could do this at the beginning of your program when the robot is aligned in the launch area and use this as your global 0 throughout the program. Or you could reset the yaw angle whenever you are about to make a turn. Both methods have pros and cons, which we will discuss later. Next, you will want to specify how fast your robot will be turning, so we are adding a set movement speed to block. For the speed value, keep in mind that any sensor on the LEGO robots usually reports their value every 2 milliseconds. You will learn why this is important in one of the next steps. For now, we are setting our value to 15%. Next, we will add a move steering block. In our example, we are setting the turn severity value to 100 for an on-the-spot right-hand turn. Most of the time on the FLL table, you will want to make tight turns in between mission models. But you can choose whichever number for the turn value. Now we need to tell the robot when to stop turning. For this, we will use a wait until block from the dark yellow control category. Into that block, we need to insert a green operator that compares if the first value is greater than another value. The first value we can grab from the light blue sensors category. By default, the block is set to pitch angle, so you will have to change it to yaw. The second value will be the angle that you want the robot to turn to. In our example, since we are turning to the right, we use 90 degrees, but any number will work as long as it is greater than 0 and smaller than 180. This is an unfortunate limitation of the Spike Prime robots. The yaw angle sensor can only read from negative 180 degrees to positive 180 degrees and does not continuously count past those values. This goes back to the choice of resetting the yaw angle once in the beginning of the program or for every turn. If at any point you turn your robot beyond 180 degrees, it will lose its global 0. You will have to reset the yaw angle at a convenient point during the program, where you know the orientation of the robot and use this as your new 0. Lastly, we need to tell the robot to stop moving. Sometimes other blocks will not stop the previous block and the robot might continue to turn even though we want it to stop at a desired angle. Speaking of which, you will have noticed that we specified our yaw angle to be greater than our desired angle. The reason for this is the 2 millisecond read frequency of the sensor and whatever speed you entered for the move steering speed block earlier. If we were to make the operator block compare if the two values are equal, the robot might skip over the exact angle we specified and spin forever. With the greater than operator block, the robot will stop as soon as the value is greater than the desired angle. This is also partially the reason that the robot will overshoot the desired angle. The faster the robot turns, the more it will overshoot. To get closer to the desired angle, check on the hub dashboard how much the robot overshot the turn and consider subtracting the overshoot amount from the desired angle you specified. Now for left turns, a few things need to be changed. The positive right turn value in the move steering block needs to be changed to a negative left turn value. The operator block now needs to look for a yaw angle value that is smaller than, and the desired value should now be negative. If you are using a global reset for your yaw angle, the target angle might not necessarily be negative. It might just be smaller than the current reading of the yaw angle sensor. For example, if in a previous right turn, the robot turned from 0 to 90 degrees and now needs to turn left to get back to 45 degrees, you would use the logic for a left turn, but specify a positive 45 degrees as your desired angle. In order to save some time and steps while programming, you could keep the steps for a right turn and a left turn on your programming canvas and copy and paste them into your program whenever you need them. A better way to also clean up your blocks and shorten your program would be to use MyBlocks. To create a MyBlock, go to the MyBlock category and click the Make a Block button. In the pop-up window, specify a name for the MyBlock and then add inputs for turn value, speed, and angle with respective labels before or after each input for ease of use. In our example, we are creating a MyBlock for a right turn. You will see in a moment why separate labels for the inputs make sense. When you are finished adding inputs and labels, click the Save button on the bottom right of the window. This will create a new type of block that is used as a header to define the MyBlock. Now you can attach all of the steps for the right turn with or without the yaw angle reset, depending on your choice to do one global reset or reset every time you want to make a turn. Then you must drag and drop the oval inputs from the MyBlock definition block to the respective fields as shown. This is what the finished MyBlock definition looks like. This definition will live on the programming canvas of this project beside your program. You can move it to the very top or off to the side, just don't delete it. If you want to use the same MyBlock in other projects, you will have to make the same block in the new project, and then copy and paste the steps over from the previous project. For that, you can separate the steps from the definition header, click on the first step, press Ctrl+C on your keyboard, switch to the other project, and on the other programming canvas, press Ctrl+V on your keyboard. Then you attach the copied steps to the definition header of the new MyBlock. Whenever you want to use your right turn MyBlock, drag and drop it from the red MyBlock category and attach it to your program. Enter your turn severity value, speed, and desired angle minus the potential overshoot. In our example, we do a global reset of the yaw angle sensor, let the robot drive forward for 1.5 rotations at 50% speed, then do a 100 type right turn at 15% speed to the desired angle of 45 degrees.
We hope this brief overview of how to make precise turns using the yaw angle sensor and saving the steps for it in a MyBlock is helpful. Good luck with all your programming efforts.
Thanks for watching. Please consider subscribing and let us know if you have any questions in the comments.